Hey guys, welcome to what might be my 8th or 9th video on A-level physics P5. I've sort of lost count at this point. So let's get into this. So we have a fairground ride and it is carrying passengers in chairs attached to a metal rod. Attached by a metal rod to a rotating central pole. And this is shown in figure 1.1. And when the pole rotates with angular velocity omega, the rods make an angle theta to the vertical, right? And the suggestion is that the cos of theta is inversely proportional to omega squared. So we have to design a lab experiment using a small object to represent an occupied chair to test the relationship between theta and omega. Right, and you need to pay a lot of attention to all of these points and because this has to do with circular motion topic. You know what omega is? Omega is 2 pi over t. So it's basically omega over t. That is the amount of angle or the amount of angular displacement in a given time, or 2 pi over t, which is one complete oscillation, and t, capital T, being the time period of what said oscillation. So technically, when one changes, so should the other, right? And we also have the whole omega not being affected by our thing. That is, the length of the rod shouldn't have any impact. But the thing is that this angle isn't exactly the angle they're talking about. It might as well have an impact. So it is likely completely irrelevant because that is not the angular displacement that is covered. That is a constant displacement, angular displacement relative to the central pole and the metal rods. This is a misconception you shouldn't get into your head. You're going to mess up. So independent variable is omega. Dependent variable is theta. What is the controlled variable? Well, obviously you want omega to be the same, to be a constant. So the power supply or the motor that causes the central pole to rotate ought to have a constant power supply, right? So there should be an ammeter to ensure that the power supply to the motor and therefore to the central pole is a constant, right? I've sort of forgotten the circuit symbol for a motor. I'll check that out. And any other thing that needs to be the same each time. Just to be safe, we can make sure that the length of the metal rods are the same each time. Maybe even the mass of whatever object is being moved around. Because for now we don't have any idea of all the stuff that might actually influence our results. Right? So you change the value of omega by changing the value of the current that is being given to the motor. And to get what the value of the omega is, you can actually videotape all of this arrangement and time how long it takes for a given number of oscillations, right? And from that you can get what omega is, right? For different values of current through the motor, right? And you may use a fiducial marker to mark one complete oscillation, right? An ammeter may be connected to the circuit to show that the current is the same each time. And how do you know what theta is? It's a bit difficult to get the value when the thing is actually moving, right? So what you think is you can do is that you can take snapshots of it at nil magnification, and you can measure the angle on the snapshots. The angle is going to be the same. That is something you can do to get the value of the angle. Or you may project a protractor onto the whole thing and read off the value that way. And one thing you can do is to let the operator stabilize before you take the value of theta. So that theta is a constant, and for each value of omega you can take theta several times and then take a mean of your readings. And then you can take cos of all of them, and because omega is basically what the independent, you can plot cos theta on the y-axis against the square of the omega value. And because it is just 1 over omega squared, or maybe if you take 1 over cos theta against omega squared, and if you get a straight line through the origin, then the relationship you thought is the correct one. Safety precautions: you might want to have safety goggles in case whatever mass is being carried gets dislodged and hits you on the eye. Probably not going to be a pretty sight if you don't take the appropriate precautions. So you can show on the diagram any sort of mass. You can show this being connected to a power supply with an ammeter. I don't think it's necessary to draw the motor, but I guess power supply, DC power supply with an ammeter ought to be enough to show the connection. Same sort of mass each time. You might mention or draw a stopwatch if you wanna, up to you entirely. So we take a look at the mark scheme. They're saying we have to ignore any reference to keeping the mass a constant. So if we wrote that, they aren't gonna mark it wrong, but they have indeed said we have to keep the length of the rigid rod constant. So it's kind of like maybe has to do with the whole pendulum thing, in which the time period is affected by the length. Something like that, but you don't really need to know that. So label diagram with object and pole attached to a rotating device, as I said, and unfortunately we indeed have to show what the motor is. So my bad, I forgot the circuit symbol. Method to change the speed of the rotating device. Yep, if you change the amount of current. To determine the frequency, stopwatch to time a number of oscillations. Revolution counter, tachometer, light gates connected to a timer, frequency meter, whatever. Use of fiducial marker, I believe I mentioned that. On light gates perpendicular to motion of object, so you know when one complete oscillation has been achieved. Method to measure angle, use of protractor or rule for measurements, or trigonometry method. So plotting a graph as mentioned. Unfortunately, goggles aren't allowed. You have to use a protective screen in case mass attaches. I honestly don't know why goggles doesn't make sense. It's going to be a bit difficult to do all of this through a screen after all. So unfortunately 2 marks might be cut, and I'm feeling a bit disheartened at the moment. So large motor to produce measurable theta, that is obvious. Additional detail on measuring angle, large protractor fixed to pole or projection method. Slow motion, freeze frame video camera with detail, yep. That isn't necessary because we went with this method of checking that the pole is vertical. Additional detail on measuring velocity, time 10 rotations, wait for motion to become stable. So we said 3 staff, they wanted at least 4, 1 mark cut over here. And unfortunately, another over here, so 2 marks are cut. I still think you'd have gotten 13, minimum 12 if you did what I did. So let's not get disheartened. Not my best video, but hopefully I'm gonna get better. Thank you guys. Please like and subscribe if you like my video or any future past ones. Thank you.